Hello, geometry. Welcome to section 4.2. We're talking about angle relationships in triangles. This video is going to be here in class as well as on YouTube at youtube.com/AHSmath. It's already up there right now and you can check it out if you want. But yeah, so no excuses. These notes are here for you guys to walk through. I'm going to be pretty specific with them. We're going to go through them pretty quickly in class. If you haven't already, let's go ahead and write our names in here. My name is Mr. Butler. This is period well, it's either 5 or 6, depending on what time. And the date today that we're doing this is the 9th, 11/9/12. So let's get started. We got angles going on in this triangle, as in three-angle type shape. And those three angles are all related in a very specific way. One of the ways that we're looking at in particular is this angle here in this corner, and this angle here in this corner, and this one here in this corner. Now we've actually mentioned this once or twice in class where we know that these three angles add up to 180 and where I can prove that to you. Let's say I kind of cut each of these angles off, right at their edges here. And so I'm going to take each of them off. And I take this one, bam, there it goes. Okay, so that angle's out. I take this one and whoa, there's that one. And then I take the third one, whoa, there's that one as well. So I have these three angles. And I'm interested in what's happening with them. Well, the thing that's pretty cool that we can notice is that these angles actually will make a straight line in kind of an interesting way here. So if I'm starting to put these two together, it looks like if I take this one, well, I could flip it around maybe and put it right in there. Let's do that. So if I flip this around, it looks like it fits right in here perfectly. In fact, it does fit perfectly. And if it's difficult to see this, let's kind of fade each of these out just so you can see them all matching up perfectly together. So if we were to straight line right here, they make a straight line. And that's, so then, in other words, we take this angle plus this angle, all three of them together make a straight line, and a straight line makes 180 degrees. So that brings us to our first. The sum of the angle measures of a triangle. So in other words, this one plus this one plus this one is 180 degrees. Fill that in. It's in your notes. Yes, this is in your notes. Fill it in. That means that measure of angle A plus measure of angle B plus measure of angle C equals 180. Example that kind of uses that idea. Now that's exactly easy, or obvious I should say, but it's really not that hard because we just have three triangles here, 1, 2, and 3. We're going to start with the third one and work our way back. And there's some information in here that's marked on the picture, but I just want to make sure you understand what it means. This angle here, K, and this angle here, those two angles that are shaded in, they're equal. So the shaded angles are equal. You don't have to write this down, but just know that the shaded angles are equal. Okay, so then this 48 and this 88, if I put those two together and then I try to add in this third angle here, oh, there's an angle missing, or a letter missing. There should be an M down there. Sorry guys, that should be there. Go ahead and fill that in. So in part A, when I'm trying to find measure of NKM, I know that measure of NKM, which is this one right here for part A, plus 88 plus 48 equals 180. And then I can work my way backwards from that. So 88 plus 48, that's 136. And then we got this angle that we're talking about. So measure of angle NKM. I'm going to subtract 136 to try and solve for that specific measure. And that gives me that measure of angle NKM equals, okay, that's going to be 44. So this angle right here is 44 degrees. I'm going to mark it in there just so I'm sure that's what it is. All right, JLK. So JLK. So just a moment. Sorry, I noticed something here. This should be an N. I'll go back and get that. Okay, so JLK. I'm looking at this right here. This angle. Now I don't think that, I think it was actually JKL. So I'm going to find all these angles. We'll just find them all. I know that this angle here, 44, and 104, and then all three of these, let's mark it in red so you guys can see it. Those three together make 180. So I got 44 plus 104 plus something equals 180. So if I put those together, I get 148 plus an angle equals 180. And if I subtract 148 from each side, then I'll get that that question mark angle is going to be 32. So right in here, this is 32. Now, if I look at the next one here, I can find JLK, which is the up here. Up here, let's mark that in green. Let's move to a different color now, green. So we're looking for this green corner. I know I have 70 and 32. Together, those make 132. So 70 plus 32 plus the green angle is going to equal 180. So I got 102 plus that question mark equals 180. Subtract 102, subtract 102. That question mark then is going to be equal to 78. So this up here, that's 78. Okay, now there's only two other angles that we haven't gotten to. I'm going to do one of these in purple right here. So this is the final angle that we're going to be looking for. One thing that I do want to note is these two angles were equal. That first angle I found, so that means this one here as well is 44 degrees. So now I'm going to look for this purple angle, and that's going to give me 44 plus 104 plus that third one is going to equal 180. So 44 plus 104 plus the third one is going to equal 180 degrees. Now this is kind of interesting because look at the red, look at the purple. It's actually the exact same, so I'm going to use the work I already did and help that give me an advantage here. That means that this question mark is 32 degrees, that this piece right here is 32 degrees. Alright, so those are all the angles. That was a good example. If you need to have this paused, tell the teacher to pause it now because I'm about to move on in 5, 4, 3, 2, 1. Alright. So now we have some corollaries. 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 That's always a weird word to say. Corollary. These are like mini theorems. They're a theorem that's so easy to prove that it's really not a big deal. And if you need to look them up, they're on page 224. Okay, so let's talk about the first one. It's about the acute angles of a right triangle. So I actually just started to give it away here. It's the acute, in other words, the small angles, not the 90-degree angle. We're talking about D and E in this case. Are. Well, let's think about this. The three of them add up to 90. So 1 plus the next plus the third one equals, or they don't add up to 90, they add up to 180. And if I know in a right triangle that one of those is going to be 90, then I subtract 90, subtract 90. Then those two leftover pieces, the acute ones, are always going to be 90 because the third one has to be that right angle. This piece here that's 90 degrees. So that means the acute angles of a right triangle are complementary. In other words, angle D and angle E are complementary. That means measure of angle D plus measure of angle E equals 90 degrees. Similarly, not exact, but similarly, the measure of each angle of an equilateral triangle, in other words, one of those that has all the same sides and all the same angles, is 60 degrees. Because if it has to add up to 180, but it's got to be split in 3, 180 divided by 3 is going to be 60 60, 60. In other words, we have measure of angle A is equal to the same as measure of angle B is equal to the same as measure of angle C, and they're all 60. Because that's the only way you get 180 from three angles that are. So let's do some examples that are dealing with that idea. One of the acute angles in a right triangle, so I'm going to go ahead and draw a picture here of a right triangle. One of them is 22.9 degrees. What is the measure of the other acute angle? Well, it's a right triangle. I know this is 90. That's 22.9, and then I don't know what the third one is. Well, let's solve for it. We have 90 plus 22.9 plus that third one equals 180. But according to our corollary, we can take off 90 and we just have 22.9 plus that other angle that we don't know is 90 degrees. So now when we solve and we get this by itself, the question mark would become 90 minus 22.9. Calculating that, we would have 67.1. Excellent. All right, let's do this same process again, but now with just some different angle measures. So for example, this one, 63.7 is one of the angles. Then we have 90 degrees. The question is what's the third one? Well, we know if it's a right triangle, then we got the 90 plus the 63.7 plus the third one equals 180. But let's shortcut that, and we'll say that it's just 63.7 plus that second acute angle equals 90. So we subtract 63.7, subtract 63.7, and that question mark, the angle in question is 90 minus 63.7, which in this case would be 26.3. Okay, for this next one, again, we have two angles. This time we don't even have a number, it's just x. But we know that 90 plus x plus the third angle is going to equal 180. And then shortcut, x plus that question mark equals 180. Or plus equals 90. Whoops. Mistake. Double check that. Good thing you write in pencil, huh, guys? Okay, so then we subtract x, then the question mark is going to be 90 minus x. Oh, fractions. Those are fun. Fractions are fun. That's why they start with the letter F. So now we have the same idea. I'm going to shortcut this one completely. We have 48 and 2/5 plus something equals 90. Okay, so I'm going to show you guys something here real quick. First, I'm just going to subtract the 48. I don't have to subtract all of it. I'm going to show you how you can do this piece by piece. That means the question mark plus 2/5 equals 90 minus 48, which would be 42. So if I subtract 2/5, that question mark is going to equal 41 and 2/5 less, which would be 3/5. Because when you have 2/5 gone, there's 3/5 left over. Okay. Remember, tell the teacher to pause it if you need it, because I'm going to move on in 5, 4, 3, 2, 1. All right, exterior angles. So what's happening here is we have these two angles here, and this angle here, and this outside angle that's opposite those two interior angles, sometimes we call those like the remote angles, is actually equal to their sum. So we have the interior right here, and the exterior is out here, if we're to talk about as interior and exterior. And those two angles are going to add up to that one. So the measure of an exterior angle of a triangle is equal to the sum, in other words, we got to add these two together, of the measures of its remote interior angles. So notice that if we had labeled these 1, 2, 3, 4, we're looking at 4, and we don't want 3, we want the other 2 out here. So 1 plus 2 equals 4. That's kind of weird, but the measure of angle 1 plus, or measure of angle 4, pardon me, is equal to the measure of angle 1 plus the measure of angle 2. Let's use that idea. By the way, pause it if you need. I'm moving on. That's just to fill in the blank. Let's do the examples. So looking at this example here, I have 101 for the outside. Remember, it's the outside equals the 2 in plus the in. So the outside piece is 101 equals the other two added together. In this case, 75 plus the question mark. So then if I were to subtract 75 from each side, I would get 26 equals the question mark. Well, that was pretty easy. So that question mark equals 26 degrees. Okay, this next one, almost identical. And you could probably do this one in your head. The outside equals the inside plus the inside. So we got 100 is going to be 50 plus a question mark. Okay, beat me to it, guys. I know you can do this. Shout it out if you want. 50 is the question mark. Okay, so let's do another one. It's similar. It's got a slight difference in this one, so kind of be careful here. You know, that outside piece is going to be equal to the other two added together. This time we don't know the outside, but we know the other two. There's 66 and 26. So this time I don't need to do subtraction, just combine the 26 and 66. That would give me 92 equals the question mark. Okay, for the next one here, we have the same idea. The outside equals the two inside added together. The outside is a question, but the two inside are 51 and 23. So if we add those two together, we'd get 74. And that is our question mark. So that's 74 degrees. Okay, this one's a little bit smaller, but we got 50 and 52 here. If you want, you can ask the teacher to pause it if you want to try this one on your own. Actually, I'll do this. I'll give you 20 seconds. Ready? Go. I'll just put the setup here. You guys finish it. Okay, I'm done waiting. I don't know if that was 20 seconds. Question mark is the exterior. The two interior are 50 and 52, which makes the question mark equal to, everybody now, 102. Okay, the next one. We're looking at these three pieces. I want you guys to try this one as well. I'm going to count to 20 in my head. Let's see if you can get it. Wow, that took a long time. Hopefully you guys got it by now. So we got the outside piece, which is 148. The inside pieces, I got 78 plus the question mark. So I'm going to subtract 78 from both sides. That's going to give me 8 minus 8 is 0. 14 minus 7 is 7. So 70 equals the question mark. This would be 70 degrees. Okay, again, remember, ask the teacher to pause it if you need. I'm going to count down from 5, and then I'm moving on. 5, 4, 3, 2, and... All right, same idea, but more complex. Why is this one more complex? Just look at the obvious kind of stuff. I look at this and I see x. Ooh, that means equations and stuff. So we're doing the same thing we did before, but now we have to solve an equation for x. But the setup is the same. We have an outside one equal to an inside plus another inside. And in this case, the outside is 16 plus 11x. And the inside pieces are 100 and x plus 16. So now if I start to put all this together, let's see what we can combine. I know that I can combine the 116, so it would give me 116 plus x equals 16 plus 11x. Let's subtract 16 from both sides. Then I'll have 11x equals 100 plus x. So I'm going to subtract this 1x from both sides. That's going to give me 10x, because that's really just a 1x, equals 100. Divide by 10. X equals 10. Check. That was awesome. Pretty easy there. Let's do another one. Same template. You have the outside equals the two inside pieces added together. So then let's plug in the pieces that we have here. The outside piece is 127 right there. And the inside pieces here and here are 26x minus 3, kind of low on space. 16x plus 4 is the other one. Now, common error is people try to subtract x from two terms on the same side. Notice that these two terms are on the same side. So when you have two terms, same side, all you can really do is combine them. So I'm going to combine 26 and 16. That gives me 42x. Similarly, I'm going to combine negative 3 and positive 4. It gives me plus 1. So 42x plus 1 equals 127. Then I subtract 1 from each of these. Then I'll have 126 equals 42x. To get that x by itself, I got to divide by 42. And x is going to be equal to 3. Awesome. Okay, this last one, it's actually, I think, simpler, but one of the things that's kind of different in here, so we got to find the measure of ACD, but that means we got to solve the equation first. Now there's some information in the picture that's kind of obvious but not so obvious because they're not saying it out loud, but they are pretty straightforward with it. And that's about this angle in the corner here. This angle in the corner is 90 degrees, and we need to know that, because this angle A and this angle B are two interior angles that are going to find this exterior angle there. So let's see what we have then. That means we got the outside. It's going to equal the two inside added together. So we'll have 6z minus 9. It's going to be equal to 90 plus 2z plus 1. So I got some working to do here. I'm going to combine the 1 and the 90. That'll give me 91 plus 2z is equal to 6z minus 9. Now I'm going to move these z's over, so I'm going to move 2z over to the left. That'll give me 4z minus 9 equals 91. And if I add 9 to both pieces, I'll be left with 4z equals 100. If you divide both sides by 4, we get z equals, beat me to it, it's 25. Very good. Done, right? Oh, no, we're not done. It said find the measure of this angle. We know that z equals 25, so when you got to find a measure, you got to plug it back in. So that's 6 times 25, and then subtract 9. Well, 6 times 25, that's like 6 quarters, $1.50 or 150 minus 9. So that's going to be 141 degrees. So now we know it. We know what this angle is. It's 141 degrees. Okay, let's jump to the next one. Now we're going to be talking about third angles. Third angles. That just really means the third one here and here. If we know the first two, then what do we know about the third? Well, let's fill this in right here. If two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are also congruent. So in other words, L is congruent to R, and we know that by these markings. See how this has a single arc, single arc? That means that those are congruent. We also know that angle M is congruent to angle S. You should probably fill this extra information in here because it's got a double arc, double arc. Then the third one has to be true. Why? Well, let's think about this. Let's say we have Tony and he's got 3 bags. And then we have John and he's got 3 bags. And in these 3 bags, we know that all together that it's $180. And in his 3 bags, we know that all together they're $180. And let's say that this blue bag that I'm about to draw blue from Tony is the same as this blue bag from John. And then this red bag from Tony is the same as this red bag from John. Then that means the third one has to be the same, that this purple one and the purple one match as well, because that's the only way that the 3 things could add up to 180, because all 3 angles add up to 180. So what's our conclusion then? That third angle, angle N, is congruent to angle T. So let's use this idea. So we know that A and D match. Excellent. B and E match. Then we know that C and F also match. So we can set those equal to each other. We'll have y squared equals 3y squared minus 72. Well, I'm trying to get this y by itself, so I'm going to move the 3y over to the other side. We'll subtract 3y squared from both sides. Remember, this is 1y squared. 1 minus 3 is negative 2y squared, and then the other side equals negative 72. So we divide by negative 2. And that's going to give me y squared equals 36. And when I take the square root, y is going to equal 6. Now here's the cool thing. These 2 angles are equal. I could plug it into this equation or this expression with 2 terms, or I could plug it into this expression that only has 1. If I know y equals 6, then that means that y squared is 6 squared, which is 36. So what's the measure of angle C? Measure of angle C equals 36. What's the measure of angle F? Well, it's the same thing, so I don't have to do any more calculation. It's 36. So part B is actually very similar. Right now would be a good point to ask the teacher to pause it, because then you can try it on your own. But I'm going to go ahead and push through here. I know that because the first 2 angles are the same, that the third one is also matching. So angle P and angle T are congruent. That means that 2x squared is equal to 4x squared minus 32. Well, let's get rid of this 4x squared so we can start doing some dividing. That gives me negative 2x squared is equal to negative 32. If I divide by negative 2 on each side, then I'll have x squared equals 16. Then x equals 4 if I square root both of those. So x equals 4, it's asking me to find the measure of each of these angles. Well, let's try this one. We're going to have 2 times 4 squared, which is equal to 2 times 16, which is equal to 32 degrees. So what's the measure of angle P? 32 degrees. What's the measure of angle T? 32 degrees. Excellent. Pause. I'm about to move forward in 5, 4, 3, 2, 1. Okay, let's practice this idea. So similar idea happening here. Let's just work it out. We know that 4x squared and 3x squared plus 25 are equal to each other. So 4x squared equals 3x squared plus 25. If I subtract 3x squared from both sides, I get x squared equals 25. And x then equals 5 because that's the square root of 25. So I got to plug that in. Right here, this is 4 times 5 squared. 5 squared is 25 times 4. That equals 100 degrees. And what's the other one? It's also 100 degrees. Okay, this next one I think is pretty easy. Some people think it's harder because it's not squared, and that to me is actually easier. So let's work it out. We know that these two angles and these two angles match, so then the third angle has to match as well. That's what the third angle theorem says. First two match, and the third one also has to match. So that means 5x minus 11 equals 4x plus 9. I'm going to add 11 to both sides, and I'm going to do two steps in one here. I'm also going to subtract 4x. That gives me x on the left side because the 11's cancel out. Then the 4x's cancel out, and I just have 20. So x equals 20. But I still got to find the measures of each. So that means I got to plug this back into here. So I'll have 4 times 20 plus 9. That gives me 80 plus 9, or 89 degrees for both angle U and angle S. I know this next one, it's easier than you would think. Even though there's no pictures, let's just kind of follow what's happening. Angle A is congruent to angle X. Okay. Angle B is congruent to, or is equal to angle Y. Pardon me. They're equal, and then these are equal. So that means that angle C and Z must also be equal. So 4x plus 7 and 3 times x plus 5 have to be equal. Well, let's see what would happen. We have 4x plus 7 equals 3 times x plus 5. If I were to distribute this 3, that gives me 3x plus 15 equals 4x plus 7. Then we can start doing some algebra here. Subtract 7 from both sides. Subtract 3x from both sides. That's going to give me x on the left side and 8 on the right side. The 3x's are gone and the 7's are gone. So now I know that x equals 8. I can plug it in. So I'll have 3 times 8 plus 5, which is 3 times 13, which is 3 and a 9. 39 degrees. So these are equal to 39 degrees. We only have 2 more pages after. And they're both very advanced level type questions. So if we can at least finish this, then I'll be mostly happy. But I do want you guys to work a little on the advanced. Okay, this next one, piece of cake. It should take you like 2 seconds. The third angle here is 35. So what's x? It's 35. And in fact, this shouldn't say measure of angle G. It should have said measure of angle P. And it equals 35 degrees. So this next one says measure of angle T and measure of angle V. I have 2 of them. What am I going to do? Well, these 2 match these 2. So then the third has to match the third. That means that 10n minus 2 equals 9n plus 9. So I'm going to add 2 and subtract 9n. That gives me that n equals 11. Now if I were to plug that back in, I could do it to either one. Let's do it to this one here. That means 9 times 11 plus 9. Or 99 plus 9. Or 108. 108 degrees. Okay, for this next one, I want you to try. You try it. I'm going to count to 20 again in my head, and while I'm counting to 20, you guys go ahead and try and work it out. Okay, hopefully you guys got it by now, but how do we start this? Well, we got the two pieces equal to each other. 5x plus 4 and 6x minus 4. Subtract 5x, subtract 5x, add 4, and we get 8 equals x. Then we got to plug it back in. Let's do this one here. That means 5 times 8 plus 4, or 40 plus 4, which equals 44 degrees. And measure of angle E is 44 degrees. Alright, let's jump to the multi-step problems now that we kind of understand this 180 and matching pieces and all that kind of stuff. So this first one says find measure of angle A, which is this one here. But in order to do that, I got to set up these equations in a way that helps me work backwards to get that angle. So let's start with what I know. I see three angles. They're on the inside. I know that the three angles add up to 180. So that means that 70 plus 6x minus 4 plus 7x minus 3 equals 180. Now again, I got a bunch of stuff on one side of the equation. For me to simplify from here, I just need to combine. So I got negative 4, negative 3, that's going to be negative 7, and I got this 70. Then I got 6x and 7x, that's going to be a plus 13x. So I did a little bit of simplifying there. I'm going to do a little more. 70 minus 7 is going to be 63. So that's 13x plus 63 equals 180. Now I subtract 63 from both sides. And I'll have 13x equals, this is going to be 117. Now if I divide both of these by 13, 13 goes into 117 9 times. So x equals 9. That's a start. But I got to plug that in to the angle A. So that means I have to plug into 7 times 9 minus 3, which is 63 minus 3. So what's this angle? It's 60 degrees. So how do we do this? We know that three angles add up to 180. We plug that in, simplify, solve, find x, then plug it back in. Let's do it again. I'm going to have three angles. They're going to add up to 180. So I'm going to set this up for myself here and then just put the pieces in. I know I have 80. I also have x plus 64 and x plus 54. So I got to combine. I got 1x, 2x. So that's 2x. Now 54 plus 64 plus 80, that's quite a bit. It's going to end in an 8. And let's see, how could we simplify this? That's 144 plus 5. Okay, x is going to be negative. That's kind of weird, but it's okay. X can be negative. That's going to be 118 plus 80, which is 198. So when I subtract 198 from both sides, I actually get a negative number over here. It's going to be negative 18 equals 2x. And when I divide by 2, x is equal to negative 9. If I'm trying to find measure of angle A, that means I'm going to plug in here, negative 9 plus 54. And negative 9 plus 54 is actually going to be 45 degrees. So measure of angle A equals 45 degrees. This third one, I would like you guys to try it. Feel free to ask the teacher to pause it right now. I'm going to go ahead and work it out, but if you would like to and there's enough time in the class, go ahead and pause the video so you guys can try this. If you pause the video, well, welcome back. And now I'm going to solve it. We have the three pieces, in this case 68 plus 17x plus 12x minus 4 all adds up to 180. So let's combine. 17x and 12x, that makes 25x. 68 and negative 4 makes 64. And those together add up to 180. So I'm going to get x by itself. I subtract 64 from both sides. I get 25x equals, what's this going to be? 116? Oh, 29x. Whoa, look at that. Mr. Butler can't add. 17 plus 12 is 29. X equals 116. I was like, that doesn't seem right. Those numbers aren't going to go in evenly. And usually a lot of these equations do. So this is 29x. Hopefully you guys caught that. So I'm going to divide both sides by 29. And it goes in there evenly. X equals 4. So if I want to find angle A, I got to do 12 times 4 minus 4. That's 48 minus 4. Or 44. That's a lot of 4s all over the place. Let's scroll down a little bit here to. Okay, why is this one harder? Well, we got this weird shape with pieces all over the place, but we need to remember something. We need to remember that vertical angles are congruent. So if this says 95 outside, this is also 95 inside. And if this says 5x plus 15 outside, it's the same inside as well. That tells me that I have those three inside ones now that I can set up as an equation. But I had to remember that vertical angles let us kind of have some congruent relationship to get to the inside. So then I'm going to have 30 plus 2 more angles equals 180. So you have 30 plus 95 plus 5x plus 15. So 30 plus 95, that's going to be 125 plus 5x plus 15 equals 180. 125 plus 15, put those together, we get 140. Then we still have the 5x. I'm going to swap places with them. So I subtract 140 from each side. It gives me 5x equals 40. And if I divide by 5, x equals 8. And that's all it had me do. Solve for x. X equals 8. Let's look at this next one. We got this same congruent vertical angles, these two here, so that means this is going to be 55 degrees. Now this one's a little bit different. It's not congruent. If it were congruent, this would be 135 over here. And this inside piece is definitely not 135. It's less than 90 degrees. It's an acute angle. But what I do know is that these two together make 180. So if this is 135, then I could figure that one out. Or even better, we just learned a new theorem. Do you guys remember it? Do you remember it? It was the exterior angle theorem. Look at this. 135 is going to be the same as these two pieces added together. So let's use that. The exterior angle theorem, where the two inside pieces add up to equal the outside piece. And in this case, the outside piece is 135. The two inside pieces are 55. And 81x minus 1. All right, time to simplify. We have negative 1 and 55. Put those together, we got 54. If I subtract 54 from each side, let's see what happens. We're going to have 81x, I'm jumping down here, equals, so we're going to have a 1, and then 13 minus 5 is 8, so that's 81. Hey, that's convenient. If I divide by 81, x equals 1. That was awesome. Super convenient. Alright, we have a very similar idea happening here, where we're going to put 7x plus 4 on this inside piece, and then that gives us two inside angles equal to an exterior angle. So let's set it up and then we'll simplify. The exterior angle equals the two other pieces added together. So the 112 is going to be 7x plus 4 plus 66. So that means that if I simplify this, 112 equals 7x plus 4 and 66 makes 70. Now I can start solving again. Subtract 70 from both sides. That'll give me 92. Is that right? 92? No. 42? Yeah, 42. Goodness gracious. How did I get 92? That's just weird. So we have 42 equals 7x. Now if we divide by 7, x equals 6. That wasn't too bad. You know what? Actually, I'm going to go ahead and stop the video there. I know we have another page. It's this crazy page stuff. Because similar ideas happening in it, just more complex algebra. The only thing that's really going to kick you guys is these last three. Actually, you know what? I'll do the last three. I'll skip the ones before that. What makes them more advanced? Well, these ones you have to also plug it back in to find the measure of the angle A, not just solve for x, but then you got to plug it back in. So, for example, we'd have to find these angles here. So let's look for these multi-step problems here. I know this is 59 degrees. I'll do this in blue. I'm going to scroll down here. This is 59 degrees, so that means inside is also 59 degrees. And I know that this is 71 plus 59. If I were to add those two together, that gives me 130. And all three of these inside here would make 180, so this other one needs to add up to 180. So 180 minus 130 would give me 50. So this third one here is 50. Then I can see from this corner angle that that's a right angle, which adds up to 90 degrees. So if this piece is 50, then the other piece is going to be 40, because 40 plus 50 equals 90. That was a lot. We jumped from 59 inside, then we did the sum of three angles to find 50, then we did complementary, a right angle corner to find 40. Now we can do the three angles in here adding up to 180. So we got 70 plus 40, that's 110. So this last angle here has to be 70. Oh, that's a lot of work, but still very doable. All right, let's see what we can have happening with this next picture. I see 30 and 20, and all together we have to add up to 180. Those two together make 50. So 180 minus 50 is 130. Now by vertical angles, these two across from each other are equal, so this is going to be 130 as well. Now if I were to use the exterior angle theorem, there's a lot of ways I could do this, but let's look at exterior angle theorem. That means that the question mark plus 130 is going to equal 153, because these two interior angles equal this exterior angle. So I'm going to subtract 130, subtract 130. The question mark is going to be equal to 23. Okay, this last one here, let's go ahead and work that out. We got 62 and 73. Together, those would be 135. And because the inside of the three angles inside of a triangle are 180, this third one has to be 45. And by vertical angles then, this other inside one is 45 as well. Now I'm going to go ahead and find this angle here using a linear pair. I know that this half's 180, then that means 180 minus 82 is going to give me 98. So this piece is 98. Now 98 plus 45 plus whatever this is, it's going to be 180. So 98 plus 45 plus, let's call it x, equals 180. 98 and 45 put together is going to be 143 plus x equals 180. Subtract 143 from both sides. We have x equals 37 degrees. And just by chance, by vertical angles, the question mark is the same thing, so the question mark would be 37 degrees. Alright, that is where I'm going to finish this video. I'm going to go ahead and stop it, burn it, convert it, upload it, all that stuff for you guys. Remember, it's going to be at YouTube. It already is at youtube.com AHS Math. I'm gonna make a what do you call it? A playlist for 2012, 2013 geometry. Have a good day. Work on your packets if it's already if there's still more time in class, but I'm guessing this took most of the time. Bye.